Hello and welcome back. I'm sure you enjoyed that long stretch and had a bit of a nibble to have a bite and got your energy flow back going. So now let's get in and learn about the programming about Systic. So I already opened the IDE to save a bit of time, so it's already loaded. So we'll go to File. We'll open a new project, new STM32 project, and this will allow you to choose the target selection. So it's loading. We got to wait, and it checks with the server, and it will let us to choose the target selector. So you got to connect the hardware as well, otherwise it will throw the error. So my hardware is connected. As you can see, the LED is on. I'll take this view. So it's loading on the background. So once it's ready, it will let us to choose the target selector. So there it is. So we got to patiently wait until the system lets us to use the target selection. We're going to write a program to generate 1 millisecond system tick delay. So that's what we'll learn today. And at the end of the session, you would be able to write your own, and you'll be more familiar to use that into your own projects. Okay, go into board selector, and we are using the nuclear board. So just type nuclear dash F411RE and choose that board and hit next and give a project name. Today we are on day 17, so I'll represent that day 17 and give us sys tick and start with from scratch. So I'm going to choose the targeted project type as empty and finish. This will fetch all the necessary files, and after that you will see the day 17 will be here generated. So it's generated already, so it has given all the files. So I'll close down the old open file so you won't get confused. I'll close all the main programs. So click on the source, double click on the main.c to open. As you know, this section is for reference to say what file it is, so you always need to give the file name .c and also the author who has written this program and what is this for. And also you need to give explanation about an indication where this program is going to sit, whether it's in the main program or is it in the top section or in the bottom section of the whole lengthy program. So you need to say that. And also this is a little bit about the license to tell that you are using the licensed STM32 microelectronics board. So go into the program. I will delete the internal default files and we'll start from scratch. First I will right click and build for the .elf file. So right click, build project. This will start to build and it will generate the .elf file. It's loading. See, .elf is generated, .elf. Because that's the one you need to use to download to your board. So that's the first step. You need to always remember to do that. And then before also writing, you can set your debug options, because the STM32F411 has the built-in programmer to debug. So by going to STM32, it chooses the .elf file by default, but if you want to use the debug configuration, you have to set it. So I'll go directly here because we build the project and therefore the .elf file is generated, so it's already linked. we skipped one step basically. Otherwise you got to go and look for it, which you have seen in the previous sessions, the other sessions. So come to debugger, make sure you enable the interface. This is the programmable link, st programmer st link, and then watching the output serial wire viewer, click enable, and then go here apply, and then say okay. So this will basically change from your C perspective to debug perspective, and that will be ready to do all your debug. And also we will be able to view all the special function registers now. It's doing 89% now, so once it's ready, we'll go into switch, and I'll go and get all the necessary registers that we need. So we need to go to window, show view, and go to SFRs. So these are all the registers Cortex M4 we're dealing with today. These are all the third party STM32 F411. So we are on SysTick timer, so we need to use all these 4 registers. So the first step is you need to declare all the pointer variables. So I'll start with the program with uint 32 underscore t, small p represents the pointer declaration. First we'll go to the status stcr, that's strvr. So this is the status control register. So copy this register, and also you got to typecast it, uint 32 underscore t typecasting, and copy the address for this register stc 12c. So if you go into the manual, so this is the STM32 manual. So if I go to SysTick registers, you can go by contents here, go directly, and if you scroll down to SysTick registers, system timer SysTick, if you enable that and go to SysTick, this is the first register. It's a SysTick control and status register. So we're enabling that by setting this register bit 0 to 1 to enable. So that's what we did. It's a SysTick control and status register. SysTick control and status register. I'll copy this because we need all the 4 registers we are using. Copy and paste it. So we need 4. So I'll paste 4 times. Oh, I didn't copy the whole, sorry. I got to type uint 32 underscore t, uint 32 underscore t, uint 32 underscore t. So first we copied. So next is the reload value register. So open this strvr. So the next register is, that's a SysTick control and status register. Next is strvr, SysTick reload value register. Copy this SysTick reload value register and declare that here, and copy its address, Control-C, and copy it here, save it. So this is SysTick reload value register. Next one is we need a SysTick current value register. So if you go there, the next one is SysTick current value register, that is is syst underscore CVR. This is the register current value. Systtic current value register stcvr. Copy this register, declare here, then copy its value address. Sorry. So this is systtic current value register. So the next one is we need STCR, and what is STCR? So the STCR is systtic calibration. STCR. So you can also say as system calib, and all these 4 registers. So that's what we are using: a current, reload, current, control, and the calibration value. So these 4 registers are the must. So copy STCR, and paste it here, and also copy its value. Okay, so this is systtic calibration register. Okay, so we declared all the necessary registers that we need. I'll just do a right click and build project to see error free. So just do a right click, build the project. We're going to see the output to make sure as the GPIO. So I'm going to show with the interrupt that we raise here through systtic, and I'm going to make it blink the LED. So that's what we're going to learn. So now we got to write a program to link that connection. So the next step is using LED. LED, as you know, it's connected to port A, pin 5, to show the generated delay by systtic. So that's why we're going to see the output. So to do that, you need basically 3 registers, as you know: HB1ENR, the port modder, and the output data register. So I'll copy this. We need this. Three lines. So I need 3 registers, so I'm copying 3. We got to modify. So the first one is GPIO because it sits in GPIO. So first you need to enable the clock for it. So you got to go to RCC AHB1ENR. So copy this register, declare that HB1ENR, copy its address, so this is to enable clock for GPIO port. Then you need to set it as an output register. So you need to go to GPIO A, you need to have the modder register. So the next register we need is GPIO A mod register, copy its address. This we covered in lengths in blinking and LED session. So if you got doubt, please go there and check, and you will get more understanding. set the output modder type on GPIO port A. As you know, the modder the modder with the register, you can use it for basically as an input, as an output, as an alternate, as an analog. So that's what you got to say, use this register. Then you need to see the output in the output data register, so therefore you need the ODR GPIO A output data register, and its address is this one. Copy and paste. This is the output data register. Okay, so now we all declared all the pointer variables, and we're going to link that to the LED to show the generation. And now let's define some macros. So to define that, just to give constant values, so I'll define the macros. Define macros. So the first one is hash define control enable. This is the first bit to enable the register. Systic. 1 U is for unsigned. 1 U, setting the first bit, that is a bit 0. U means unsigned. So we need to declare that, and we need to declare the clock source, and also we need to declare the count flag. So I'll copy that twice and modify it. Control V. So the next one is clock source. Clock source, and that's the second bit, or the third bit, 0, 1, 2, so bit 2, 0, 1, 2. And this is the clock source, and this is enable, and this will be a count value, count flag. Third one is, you can give it as a count flag, count flag, and count flag is 16th bit, so I need to shift 16 times. So this is all from the registers that we learned. There I showed you in that let's go to the IDE count flag. Yeah, okay. So we define the macros, and this is our pointer variables declarations. Okay, so we have written the enabled all the values. So now the next one is, you need to define the sysclock. So as define sysclock, we're going to use 16 megahertz. So systic load value will be systic underscore load value is, we're generating for 1 millisecond. generating 1 millisecond delay, and that's the reload value. The value is 16,000 as you calculated in that formula, so that's, you got to define that there. And then now we got to enable all the GPIOs that we're going to connect, so we can define that as well here. So this is the for the GPIOs. We need for the GPIO enable and the pin 5, and then the output LED. Define GPIO enable. So we are using port A, so bit 0, so it's GPIO enable, which is the first bit, so we are enabling bit 0 for GPIO. This is for all reference. You can write for your own understanding. If you put it in double slash, and that means anyone as a new programmer, they will learn and they know, okay, that's a bit 0 for a GPIO. So that's why I write it here, to make it more understandable through the code. So the next one is you need to connect to the pin. The which pin is pin 5. So you got to define pin 5, and you got to enable that pin. So that is pin 5 LD to connection. Then you need to define the LED, because now you define the pin. So what is that pin contains? That pin contains the LED. So LED is connected to the pin 5. Okay, so we defined all the macros and we did all the pointer declarations. So now we write the main program. So we'll go in and enable the all the bits in the main program. So to do that, first let's start from here, enabling. Control C, come here, just a simple R, enabling the first bit. Oops, simple R, enabling the first bit. Or we used to do this before, remember. Today we defined it, so I'll show you the first way and then the second way. One U, you got to enable like this, but since we defined a macro already, 1U0, so macros are nothing but like a replacement, so this value will be used for this. So instead of writing 1U00, I can just directly give as a GPIO enable. So whenever line comes there, it will know that its first bit has to be enabled. So that's the explanation of macros. The GPIO enable, then I am setting the GPIO moder. The second is the GPIO moder. You got to add that again to enable bits 10 and 11. So if you go to the LED blinking session, you need to set 0, 1. So that's what we are doing on bit 10 and bit 11. So unsigned. And then that's for bit 10. I'll show you where, just to recap for you. So we can't write a 0. So So I need to undo that and then negate that bit to 11. So if you come to the reference manual, and if you go to the AHB1ENR GPIO general purpose, elaborate that, and registers GPIO register. So if you go to AHB1ENR GPIO port, GPIO data register. Okay, let's start with the modder. I'll explain where that is. So this is the output modder. You got to set on mod 5, that's 0 1 2 3 4 5. Sorry, it's loading. Okay, so that's port A0, pin 0, that's pin 1, pin 2, pin 3, pin 4, pin 5. You need to set this as output. So to set this as an output, you need to write bit 11 as 0 and bit 10 as 1. So that's what we are writing. So you need to declare the output modder type as 01, general purpose output mode. That's what we have written here. 01. Okay. So that's the modder we declared. And the next is we'll just write a simple while loop to connect to the LED. So I'll write a simple while loop, while of 1, and I'm going to connect to the output data register. Output data register, I'm going to XOR with it, so you get the all possibilities. XOR with the LED. XOR with LED, and then let's say we will create a SysTick timer delay. Because we are learning about the timer delay, so this is where we are introducing the delay for the timer. So let's start off with a value. We generating a millisecond. Let's start off with 1000 and see the LED blink. So that's a while. Okay. So now we'll have to write a program for SysTick timer. I don't need that line. You can delete that. So write a program for void SysTick delay millisecond of argument int delay. So in here you need to load all the this is where you're going to use all these registers. So first we will use this register CSR. This is, I'm just simply copying all the registers first, and then copy this. First we need to load the value, and then we need to load these to set Control C. Okay, the reload value should be the SysTick load value. So we are just simply Ring that with SysTick load value, SysTick underscore this load value generation. Copy this. the CSR, the current status. For that you need to enable the, you got to enable the control enable, simple R, then you got to use the control enable. So this is why we declared the macro, so it's easy, you just assign the value directly. And next you need to tell which clock you're going to use. So simple R, you got to use the clock source, control clock source. Control clock source, copy. So initially the current value register should be the CVR, current value register should be 0. This has to be 0 first. Okay. Control underscore CTRL underscore clock. Okay. Clock CTRL CLKSRC. Sorry, it's has to be okay. PTCSR, okay, we declared and first set to 0, like that. So now we're generating a simple for loop for a 1 millisecond delay start. So for I equals 0, and I with the delay argument, and I plus plus, sorry, that's a typo, it's not IM, delay, yeah. So what we are checking the tick int and the count flag. That's what inside the for statement we are doing. So inside for, we are checking while the tick int and the count flag. So STCSR, the calibration register, and you're going to, and with control count flag. Control count flag. Wait until it hits 0. Then return the value. Return the value and reload again. So CT STCR. I'm going to return the value, that's a control register PT. STCSR, you're going to reset this value to 0. This is the, and get for the counter clock check. And I think we haven't declared the function on the top, so I'll go and declare this function just there. So save this. I'll right click and build the project to see for any errors, possible errors. So we finished the program, so I'm just checking. Errors. One. Return value. That's a wide and that's for far. PTCSR. So return that. Build the project again. Now 4 errors. So when you see the error, it's very nice because you're learning something and you're going to eliminate that. So while PTSCR on control flag, while class does not code equals 0. Okay. Build project. Still 2 errors. So I'm just checking what this is for. I equals 0, I less than delay, I plus plus. First using this function. So int I. Build project. This should. Yeah, that's a good sign. So now. So likewise, so when you get the error, it's always nice because you might have missed one line that you wanted to type, but you didn't really convey that. So it is very good. So you got that. And as a programmer, you need to see all those errors and then you can go line by line, is did I miss anything or haven't I enabled something. So this is all helps. So it's good that it happened. So now we are ready. Now we'll go to debug mode to see the output. Right click, debug, STM32 application. So I'll open the LED view so you can see the LED blink. So it's on debug mode, so it's there. So now I just come here and run the program to make the LED blink. So as soon as you run, see the LED is on. So we generated the SysTick timer, and if you play with this value, you can see. So I'll change this to 500. Terminate and relaunch. Still loading up 70%. So now it's downloaded. The LED is off, as you can see. Switch. Now as soon as I hit run, you will see the LED glow. So now we are in the program and I'm hitting run. Watch the LED run. See, the LED is on. So we just enable the LED and check that with the output. So it's working now. PGO output with the LED XR. I'll write again one sec. Output ODR. Still loading. Switch. So this is how you generate the LED to get the generation. So I'm running. So now the LED is on. So we generated and it's running with this cystic delay with this program. It enables STCSR, yes, and then simply resetting that to 0 with this CSR. Okay, with this I conclude the demo. Let's get back in here. So what we learned today so far, we learned about how to what it is system tick is, and how we what all the registers it's going to be used to generate that system delay. And then you learn line by line programming from first line to generate that 1 millisecond. So that's really good that you learned today. And as I told you earlier, you also set your mind as well when you develop your skills. So this is the one I would like to bring it to your notice. Today I'm going to talk about circle of control. The circle of control is what you can control yourselves. So like your words, whatever you want to speak, you need to control that. Your mood, your outfit, what you're going to eat, not always junk food most of the time, and how fit you're going to be. These are all the things you can, it's under your control. So this is your circle of control. You can decide and make a better person of yourself. So once you are good with your own circle of control, then the circle of influence will link to you to a positive link, that is your relationships with your wife, with your parents, with your family, and the close surroundings, your neighbors. You will be in a different mood, your neighborhood, your neighbors, etc. So once that is all linked, then the external, which you got no control of, when you got these two right, then the external will be linking to you generally, and then it pans out to be in a positive way. So these three are the circle that I would like to bring it to you. So the external, like the foreign policies, the political views of strangers, the economy, the weather, volcanic eruption, these are all our out of control. So these we can't do, but we can do only the control. Once you control your inner circle, that will generate a good positivity with the circle of influence, and these two will generate a very good positivity with the external, with the environment, with the universe. And please don't forget about the involvement. Write down your top 10 goals and write 10 top ideas to achieve those goals. And please spend at least 30 minutes to do your exercise to keep your fitness level up. And also spend 15 minutes to dedicate to just to meditate. So you clear off each and all the stress out of your mind, so you can be fresh. And 10 minutes to actually visualizing those goals, that you pretend that you already achieved it. and then another 10 minutes sit down and use that time to generate a flow for the rest of the day or for next day or for tomorrow. So likewise you set up that, and then 2 hours of learning and notes will get you 2 points. Please to post all your achievements. The end goal is everyone has to target for 10 out of 10, and putting that into the group, it will also motivates me that you are all learning and you are following through, and also it will shape you to be a better professional, and also the others will see your motivation and they will get, they themselves will be motivated and they will stretch themselves and do all the things. There's a combo internship coming up your way. As you know, you don't have, I didn't want to cram everything into one, so I separated into 3 different modules. So beginner you already learned, we are on day 17 on intermediate, and also there is an advanced coming up. So all these 3 will give you the overall, the full Cortex M4 knowledge that you want. So please do purchase all the 3 codes. And also, if you please stick with us for long, all these courses are on the way, and you will be the first person to know and to update your skills. You can learn all of that. I take this time to thank you personally, to thank for all of your patience to go through to learn another session. We learned about how we generate the delay through Systic, and go and enjoy that lovely break from the screen, and I will see you in the next session. And this is Arul Anbukarasu. I'm signing off on behalf of A2DG. Huru for now. I'll see you at the next session. Until then, take care. Catch you. Bye for now.